Good morning, students. In the last class, we have discussed about the carbohydrates, how the carbohydrates are classified on the basis of hydrolysis, and also on the different heads, how the carbohydrates are classified that we have discussed, including the functions of carbohydrates. Today, we discuss about the another biomolecule called the amino acids. Now, what are amino acids? Amino acids are the organic compounds containing amino group and acid means COH group. So those organic compounds which contains both NH2 group and COH group are called the amino acids. For example, see we can repeat R CH NH2 C-O-OH. You will see this is the carboxylic acid group, and this is what amine group, and this is the the alkyl chain. So this is one compound where we have the acidic group COH, and also we have the basic group of NH2. So this kind of compounds which contains both an acidic COH group and basic NH2 group are called the amino acids. In this amino acids, the COH group is present at the one terminal group. Now this NH2 can be present either at this carbon, this is your C-carbon OH, the alpha carbon, beta carbon, gamma carbon, delta carbon. So this NH2 group can be present at this carbon or this carbon or this carbon or this carbon. So we have alpha, beta, gamma, delta amino acids. But mostly we will discuss about the alpha amino acids, so which are generally produced by the hydrolysis of proteins. Okay, so alpha amino acids are the amino acids where the NH2 group is present at the alpha carbon to the COH group. Clear? So I am repeating again. Amino acids are the organic compounds that contains the COH group and NH2 group both in the same molecule. The COH group is always present at the one end, the NH2 group may be present at the alpha position or beta or gamma or delta. If it is present in the alpha position, it is called alpha amino acid. Okay. Alpha amino acid. And now the point of discussion interest is about alpha amino acids, because alpha amino acids are produced by the hydrolysis of proteins. Okay. Now these alpha amino acids are 20 in number. 20 numbers. And these alpha amino acids can be what? Can be non-essential, can be essential. Non-essential amino acids, alpha amino acids, are those alpha amino acids which are not supplied in the diet. Extra are not supplied in the diet. Already the proteins are there in the diet. From the diet, the mammalian tissues can synthesize the alpha amino acids by the biochemical conversions. Whatever diet we are taking, from that diet, the body, the mammalian tissues can synthesize this alpha amino acids with the help of biochemical conversions. And these alpha amino acids which the tissues are synthesizing are called non-essential amino acids. Like what glycine. Okay. alanine. Okay, and these are 10 in numbers. 10 in numbers. So 10 non-essential amino acids are there, which our body synthesizes from the diet which we are taking. Okay. Next one is the essential amino acids. These are again the 10 in numbers. 10 in numbers. And the essential amino acids are those alpha amino acids which the mammalian tissues cannot synthesize by the biochemical conversions. And this kind of alpha amino acids one must have to supply in the diet in the extra. So in the form of amino acids, we have to take them in addition to our diet. They are called essential alpha amino acids, like valine and many more. 10 are there. But in fact, all the amino acids are essential. All the amino acids are essential for us. These are not essential in the sense what? In the sense that these acids our body is synthesizing itself, so we need not to supply it. This is called non-essential. But these alpha amino acids are essential. These are also essential. These are also essential. Both are essential for our body. These our body is synthesizing. That's why we need to supply extra thing. For these our body cannot synthesize it, so we have to supply in our diet. Okay. Now, these alpha amino acids can be classified into 3 categories. One is neutral alpha amino acid, neutral alpha amino acids, acidic alpha amino acid, and basic alpha amino acid. So alpha amino acids are classified into 3 categories: neutral, acidic, and basic. Neutral are those where the number of NH2 group, that is only one, we have one NH2 group and one COH group. If we have only one NH2 and one COH group, that is called neutral alpha amino acid. For example, if I write H2N CH C1O. CH2, NH2, CO. It's called glycine. So glycine is the alpha amino acids where we have only one COH group and we have only one NH group. Okay. So those alpha amino acids which contain one COH group and one NH group are called the neutral alpha amino acids. Clear? Now obviously, so what will be acidic? If we have more than one COOH group is there, we have one NH group but two COH group, that is called what? The acidic alpha amino acids. Okay. Similarly, basic alpha amino acids. If you have two NH groups but one COH group, that is called what? The basic alpha amino acids. Okay. So acidic alpha amino acids like glutamic acid, like lysine. Okay. Glutamic acid can write C-double-O-OH, CH2, NH2, CH2, COH. H-O, C-double-O, COH, CH2, CH2, NH2, C-double-O-OH. You see, COH group and COH group. Two COH groups are there. It is called glutamic acid. because two COH groups are there. It's your acidic alpha amino acids. And if you come to this lesson, you will see basic alpha amino acids like lysine. You can say, H2NO, CH2 whole 4 CH, NH2COH. So we have here one NH group, here one NH group. So two NH groups are there called what? Basic alpha amino acids. Okay. So alpha amino acids are classified into neutral, acidic, and basic depending upon the number of COH group and NH group present. If only one COH and one NH group present, it is called what? Neutral alpha amino acid like glycine. If we have two COH group and one NH group, it is called what? Acidic alpha amino acid like glutamic acid. And if we have two NH group, one COH group, it is called what? Basic alpha amino acid like lysine. Okay. Now, next one. In this alpha amino acid, what much you will see? C R double C NH2 H C double O OH. This is what is the alpha amino acids. Now this nitrogen atom is having NH2. This side, this is the electron that we said. Now this is your the OH. Okay. Now this OH bond can come here, and this H can attach to this place. So we will get what? R C H NH3 plus C double O minus. Okay. So RCH NH3 plus COO minus. Here you see in this alpha amino acid molecule, we have a minus charge here in this oxygen atom, and we have a plus charge here in this nitrogen atom. Okay. So that we see one proton from the COH group can transfer into the NH2 group. So we have this COO minus and NH3 plus. Because both the minus charge and plus charge are present in this single molecule, this type of molecule is called what? A dipolar ion. A dipolar ion or dipolar ion or the Jupiter ion. Because it contains two poles, dipoles, di means two. So we have the minus charge here and also we have the plus charge here. Okay. So such a species where both the charges are there in one molecule are called dipolar molecule. Okay. Also called Jupiter ion. Now see this to this molecule. So see, if I put in an acidic medium, if this process I will put in an acidic medium, what happen? This CO minus will receive the proton and will get what? R C H NH3 plus COOH. And if I put this one in basic medium, then we will take this proton from this one and I will get what? R C H NH2 COO minus C double O minus. So in an electric field, if we have an applied electric field, okay, and this amino acid, alpha amino acid molecule will put in an acidic medium, then the alpha amino acids will receive the proton from this acidic medium, okay, and will convert into a cation. And because we have the applied electric field, this cation will migrate towards the cathode. Okay. Similarly, if I put this amino acid molecule in a basic medium, alkyl medium also, then this will receive the proton from this one and will convert to negative ion, minus ion, anion. And this negative ion, anion, will migrate to also anode in an applied electric field. So, alpha amino acids are migrating towards a cathode or anode in an electric field depending upon the medium of the solution, whether acidic or basic. If the solution is acidic medium, then the ion convert into cation, migrate towards the cathode. If the medium is basic, the ion convert into what? Anion and migrate towards the anode. But at a particular pH value, there is no migration of the alpha amino acids either towards cathode or towards anode, because the migration depends on the pH value. If more acidic, then migration towards cathode. If more alkaline, then migration towards anode. But at a certain pH value, the alpha amino acids are not migrating towards any electrode. And such pH where the alpha amino acid is not migrating towards any electrode is called your isoelectric point of that alpha amino acid. And remember, for each amino acid there is a certain value of pH where the migration stops. That means for each and every amino acid there is a certain value of isoelectric point. Okay. So this is about what amino acids. Clear? Now next we will jump to what the peptides and polypeptides. So what are the peptides and polypeptides? Peptides are the condensation products of amino acids. When a certain number of alpha amino acid molecules are condensed with removal of a certain number of water molecules, then we are getting the peptides. Okay, here one alpha amino acid molecule is joined to another alpha amino acid molecule through a bond called the peptide bond or the peptide linkage. Here you see, if I write your H2NO C H 2, if I write C H H2NO C carbon O OH. Okay, plus again if I write H N H C H R, it is one OH. So this is your R CH NH2COH. What is alpha amino acids? Alpha amino acid. Your R CH2 NH2 COH. What do you? Alpha amino acids. Now this OH of this one and NH2 of this one. Minus water. What is condensation? What is condensation will happen. We get what H2N C H R C double O N H C H R C double O OH. See, this is one alpha amino acid molecule, this is another one. Now these two are joined by what? C double O bond N. This is called what? This is called what? Peptide bond, or what? Peptide bond, or you can say peptide linkage. And this molecule is called what? A peptide. So peptides are the condensation products of alpha amino acids. Right? So whenever two alpha amino acids are condensed together, remove upon one molecule, we are getting a peptide called the dipeptide. If three are there, it is called tripeptide. Four are there, called tetrapeptide, and so on. So depending upon the number of amino acid molecules to condensed, the peptides can be what? Oligopeptide, polypeptide, or protein. If 2 to 9 molecules, 2 to 9 molecules of amino acids are condensed, it is called the oligopeptide. If 10 to 100 amino acid molecules are condensed, that is called what? The polypeptide. If more than 100 amino acid molecules are condensed together, that is called what? A protein. So next we will discuss about protein. What are proteins? Proteins are the complex nitrogenous compounds formed by the condensation polymerization of alpha amino acids. And here the number of alpha amino acid molecules are more than 100. So when more than 100 alpha amino acids are undergo condensation polymerization, then we are getting the proteins. So proteins are the polymers of alpha amino acids. When the proteins undergo hydrolysis, we will get the alpha amino acids. And these proteins are the building block of the living metals. Almost all parts of the living metal, all form of living metal contains your proteins. Your hemoglobin, your chlorophyll, your different kind of enzymes, nucleic acids. So almost all form of living metals contains what? Protein. And these proteins can be classified on two heads. One is on the basis of proteins are classified on the basis of structure, and also on the basis of what? Hydrolysis product. So on the basis of structure, this can be what? Structure or composition. Okay, so fibrous protein and also globular protein. Okay, here on the basis of hydrolysis product, the proteins can be simple protein, conjugated protein, and whatever the derived protein. So we have, basing on the composition, the proteins can be fibrous or globular, and basing on the hydrolysis product, the protein can be either simple protein or conjugated or derived protein. Now, what is fibrous proteins? Fibrous proteins are those where the peptide chains are arranged side by side, okay, to form a long fiber. And globular proteins are those where the peptide chains are joined together to form a spear-like structure, spheroidal-like structure. Okay, so these are water insoluble and these are water soluble. Okay, now in simple simple proteins are those which on hydrolysis gives you only alpha amino acids. Okay, on hydrolysis gives you only alpha amino acids. And conjugated proteins are those which contains your two kind of things. One is the proteinous substance and another one the non-proteinous substance attached. Okay, so one protein part and one non-protein part are attached to each other. That is called one conjugated protein. And derived proteins are those which are derived from simple proteins. So those proteins which are derived from the simple proteins are called the derived proteins. Okay. Now the structure of protein. The structure of protein can be of four kinds. One is primary structure, secondary structure, tertiary structure, and quaternary structure. So there are four different kind of structures are there for the proteins. Okay. So details of molecular structures is not we will discuss. Simply the qualitative ideas. Okay. So we have the primary structure, secondary, tertiary, and the quaternary. This primary structure indicates how in the proteins how these amino acid molecules are joined together through the peptide bond, and also how the different atoms are arranged in the protein. And this also you can say this is also called covalent structure of proteins. Okay. So primary structure of proteins indicates how the different atoms are arranged and also how the different alpha amino acid molecules are arranged through the peptide bonds. Okay. So indicates peptide bond of alpha amino acids and also how the atoms are arranged. Now secondary structure indicates how the different peptide linkages, different peptide chains of the proteins are joined together through hydrogen bonding. Because we have the different layers of peptide chains and the different peptide chains are again joined through the hydrogen bonds. So how the different peptide chains are joined together by hydrogen bonding, that is being indicated by the secondary structure. Okay. So hydrogen bonding of different peptide chains. And the tertiary structure. So this second structure is of two kinds. One is alpha helix structure and beta plated sheet structure. Okay. Now come to tertiary. Now the tertiary structure refers to the final three-dimensional structure that results after the twisting, bending and folding of the protein helix. So after the twisting, bending and folding of the protein helix, the final three-dimensional structure that appears, that is being indicated by the tertiary structure. Okay, and the quaternary structure indicates the how the different polypeptides bonds chains are associated to form the protein complex. Okay, next is your denaturation of protein. Denaturation of protein. So what is it? What is denaturation? A process after which the protein loses its physiological properties and also some other properties is called denaturation. And denaturation in protein can be carried out either by heating or by sucking with alcohol or by the action of bacteria. So when we will do this process also, like if you heat or you treat the protein with your bacteria or you suck the protein with your alcohol, then the protein will lose its properties and also it will lose its activities. This is called what? Denaturation. For example, if you boil an egg, so when you boil an egg, the yolk inside the egg, the protein, that becomes so hard mass. So that becomes so hard. So here the protein is losing its activities, its properties. Okay. And again, if by some process, by some reverse process, if you regain the property of the protein, that is called for renaturation. Okay. So these are the examples of different alpha amino acids. As we already discussed, alpha amino acids can be of two kinds, non-essential and essential. So these are the examples of non-essential amino acids, alpha amino acids like glycine, alanine, serine, proline, asparagine, glutamine, cysteine, tyrosine, aspartic acid, and glutamic acid. And these are the abbreviations of the amino acid molecules. Similarly, we have the essential alpha amino acids: valine, leucine, isoleucine, lysine, arginine, histidine, tryptophan, methionine, threonine, and phenylalanine. These are the essential alpha amino acids. Okay, so essential alpha amino acids are those alpha amino acids which we have to supply on the diet as extra food material. But here the non-essential alpha amino acids are those alpha amino acids which we are not supplying as an extra diet material. So whatever diet we are taking, from that diet our tissues is synthesizing this alpha amino acids. And these are examples of different kind of neutral, acidic, and basic alpha amino acids. We can say neutral alpha amino acids like glycine, alanine, valine, tyrosine, and acidic we can take aspartic acid, glutamic acid, and basic we can take example of lysine, histidine, and arginine. Okay. So next, different types of proteins. Okay. So this is summary of proteins. We know proteins are different kind: fibrous proteins, globular protein. So fibrous proteins like keratin, myosin, collagen, fibrin, and globular proteins like you can insulin. We have insulin, hemoglobin, antibodies, different kind of antibodies. And also we have simple proteins like collagen, elastin, globulin. We have conjugate proteins like hemoglobins, chlorophylls, myosin, and we have derived proteins like proteases and peptides. And see here the proteins on hydrolysis first gives your proteases, that your derived proteins. Then on hydrolysis again they gives your peptides, which on further hydrolysis gives your polypeptides. And these polypeptides on hydrolysis are giving your simple peptides. And simple peptides on further hydrolysis is giving what? Alpha amino acids. That means alpha amino acids are the monomers of the proteins. Proteins are the polymers and the alpha amino acids are the monomers. Okay. So these are about the different kind of proteins, and also we have discovered the alpha amino acids. Okay. Thank you.